So it looks like today the first question we're going to be dealing with is a science question. It reads like this. Locate carbon on the periodic table and then locate bismuth at the bottom of the group. Which has a larger atomic radius? How about carbon versus boron? Which is in the same period as carbon, just one position to the left? That question came from Stephen Leonard, so it looks like we're going to be locating some things.
Okay, cool. Yeah, so I've got a periodic table up, but first let's just talk for a minute about what atomic radius is. So atomic radius is just defined as the distance from the center of the nucleus of an atom to the outermost area of the electron cloud surrounding that atom. When we think about atomic radius related to the periodic table is arranged in such a way that it gives us an indication of how large the atomic radius of one element would be compared to another. So if we jump to my screen, I've got a picture of the periodic table here. So the question asks to locate carbon. So carbon's right here. Carbon is element number 6 because it has 6 protons. And so the trend for atomic radius is that atomic radius gets larger as you go to the left across the periodic table and down the periodic table. So, and the reason for that is that the reason that the atomic radius gets larger as you go to the left on the periodic table is, if we think about carbon and boron, I know that's the second part of that question, but I'm going to start here. If we think about carbon and boron, carbon has a smaller atomic radius than boron does. And the reason for that is carbon has an additional electron, neutron, and proton compared to boron. And protons, being positive, attract electrons in the outer electron cloud. And so because carbon has an additional proton, it's going to hold its electrons a little bit closer in a tighter configuration. And so the distance from the center of carbon's nucleus to the outermost part of its electron cloud is going to be slightly smaller than boron's, which has a slightly weaker pull on its electrons. So boron would have a larger atomic radius. And I can actually show that. Here's another picture. This is sort of a chart that indicates the trend in atomic radius. You can see a generalized size, a comparative size of all the atomic radii. And you can see that as we go left across the periodic table, those atomic radii get larger. And as we go down the periodic table, they also get larger. So here's my arrows over, I don't know if it can be seen very well, but carbon and boron, you can see that boron has just a slightly larger atomic radius than carbon, again, because it doesn't have such a strong hold on its electrons. Looking at carbon again, bismuth, I think, was the other one, right? Mm-hmm. It was down the, let me jump here really quick. So here's bismuth, which I guess is right, it's one group over, but several periods down. And so even though bismuth is to the right of carbon, bismuth is so far down the periodic table that it has many more protons and many more neutrons and electrons added, which makes its radius much greater than carbon or boron. So again, looking here, here's bismuth. It's this purple guy. It has a much larger atomic radius than carbon or boron. So, and again, the periodic table is arranged in such a way that it gives us an indication of lots of these trends, not just atomic radius, but also things like electronegativity and metallic character. And things like that can be gleaned about one element compared to another just by looking at the periodic table.